Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Kumar Engineering College, Ghaziabad. Today in this particular video, I am going to discuss about the working of 4-stroke engine, both petrol and diesel. Okay. In my earlier video, I tried to convey the basic terminology related to an engine. So, in this video, I am coming to the working of 4-stroke engines. So, engine we basically knows engine is that system through which the chemical energy of fuel is getting converted into the mechanical energy. Okay. So, we are getting work output, we are getting the crank rotation. So, and from where we are getting? By the combustion of fuel. That fuel may be petrol or diesel. So, some basic idea I would like to give here. The petrol engine, if I am talking about, then definitely the petrol engine is working on Otto cycle. It was first given by Nicholas Otto. So, it works on Otto cycle. Okay. Here I am showing the Otto cycle. So, I will be discussing this also. So, the petrol engine works on which cycle? Otto cycle. And the ignition of fuel which takes place, through the spark ignition. So, that is why it is also known as spark ignition engine. It is also known as spark ignition engine. And the third thing which is important to know here when I am going to discuss the details about the working, the heat addition in the engine is at constant volume. So, these 3 points we must know when we are discussing about the petrol engine. Either it is a 2-stroke or 4-stroke, but these things will remain common. Petrol engine works on Otto cycle. The ignition of fuel is because of the ignition of a spark, and the heat addition will be at constant volume. Now, how an engine works? So, what we need? Okay, we consider a piston cylinder system. So, what happens there? That has to be understood first, then I will be going in detail one by one. First, what we need? We need fresh air and fuel mixture. What we need? Fresh air and fuel mixture inside the cylinder. That is what we can call as a suction. So, with the help of piston, we are trying to suck the fresh air fuel mixture inside the cylinder. The second point which is important here, it is not generally possible to make the burning possible at atmospheric air, atmospheric pressure and temperature. So, then the second thing is necessary is the compression of that. Okay. So, the second step is compression. So, this is what the compression stroke. The third thing what we need now, after the suction and compression, now we can make the burning possible either by the spark ignition or by the self ignition. So, when the burning occurs, then obviously the large amount of energy will be released, and that energy we are getting from where? That energy we are getting from the fuel. That is why it is named as power stroke and the expansion stroke. So, whatever we can call, I am using the word power stroke because here we are getting the power from the combustion of fuel. Then what is required? After the complete combustion of fuel which was inside the cylinder, it has to be exhausted and it has to make the way for the fresh air fuel. So, the exhaust stroke will be there. So, these are the 4 steps in which any engine works. So, here we can discuss in this term. So, this is a PV diagram for a Otto cycle. Okay. This line is showing what? It is showing that is the clearance volume, because the total volume of the cylinder is the sum of the swept volume as the clearance volume. And why clearance volume is necessary, that I discussed in my last video. Okay. So, the first is what? The first is the intake stroke, the suction stroke. Okay. So, the fresh air fuel is coming in. So, when the fresh air fuel is coming in, then obviously the volume of the system is increasing, volume inside the cylinder piston arrangement is increasing. So, here at a constant pressure the volume is increasing, Then What is necessary? It is the compression. So, compression stroke is there. So, here adiabatic compression, because of the adiabatic compression, what is happening? The pressure is increasing and the volume is decreasing. Then the third is, what is written over here? Heat addition at constant volume. So, the spark will be ignited and heat will be added to the system. When the heat will be added to the system at constant volume, its pressure will be increasing. So, pressure is increasing rapidly because the volume is constant and burning starts. Okay, combustion of fuel starts. So, pressure is very high. At this high pressure, the expansion, adiabatic expansion of fuel takes place. The gasoline mixture which is inside the adiabatic expansion takes place. So, the pressure is decreasing and the volume is increasing. This is what the power stroke or the expansion stroke. Then the fourth step is the exhaust. The byproducts of burning of gasoline must be exhausted. So, exhaust at the constant volume. So, these are the 4 steps which occurs when a petrol engine, 4-stroke petrol engine works. Now, we can understand this by the diagram. Okay, one by one we can come to that point. So, the first thing is what? Obviously, for the suction of fuel, here we are talking about the petrol engine. So, the mixture of air and fuel means the air and petrol which is coming from the carburetor will come in, and for that inlet valve must be open. Inlet valve must be open. So, here the inlet valve is open, exhaust is closed, piston is at TDC. Piston is at TDC. Okay. So, piston is at TDC, and because of the inward movement of petrol and air, okay, the piston starts moving from TDC to BDC. From TDC to BDC, the piston starts moving. So, this is what the suction, the fresh air fuel is coming in the cylinder, inlet valve is open, exhaust is closed, and the piston is starting moving from TDC to BDC. So, inlet is open, exhaust is closed, piston moves from TDC to BDC, crank revolves half the rotation. This is the crank. So, the crank rotates by 180 degrees. So, this happens in the suction stroke. Okay. Petrol air mixture drawn into cylinder due to pressure difference, because the pressure outside is atmospheric pressure, and because of the suction, because suddenly we are pulling the piston. So, it is creating the suction at the inlet valve. So, because of that pressure difference, the fresh air fuel mixture is coming in. So, this is what the suction stroke. Now, we are reaching to the compression stroke. Now, the position of piston is what? The position of piston is at BDC. Okay. For the compression, what we need? We need to close both the valves. So, inlet and exhaust valve both are closed. Now, for the compression of air fuel mixture, what will happen? The piston will start moving from BDC to TDC, BDC to TDC. So, obviously, the air fuel mixture will be compressed and its pressure will increase. That you can also relate from the PV diagram. Okay. There also I explained the same thing. So, this is what the compression stroke, both inlet and exhaust close, piston is moving from BDC to TDC, crank revolves 180 degree again, half of the rotation. So, this is what the compression stroke, compression of air fuel. Petrol air mixture is compressed to a ratio of 1:11. So, this is the pressure ratio, compression ratio we are maintaining in the 4-stroke petrol engine generally. So, this is the compression stroke. The second stroke, why we are calling it stroke? Because the 1 stroke length is covered by piston from TDC to BDC. This is 1 stroke, BDC to TDC. This is second stroke. So, this is what the meaning of stroke here. Okay. At the end of compression stroke and before the beginning of expansion stroke, the air fuel mixture will be ignited with the help of a spark plug. So, a spark plug is there. Here is the spark plug. Through this, the spark will be ignited, and because of that spark ignition, the burning of air fuel mixture will start. Now, I am coming to the power stroke. Power stroke means the expansion stroke. Here we are getting power from the engine, power from the fuel. Chemical energy of fuel is getting converted into mechanical energy. So, here because of the expansion, because of the burning of fuel, the large amount of energy is released, exothermic reaction. Okay, exothermic reaction is there. So, it will push the piston, and piston is pushed. Piston will start moving from TDC to BDC, expansion. This is the power which we are getting from the fuel. Crank again rotates by half of the rotation. Burnt gases generate energy and force the piston to move down. So, this is the working stroke, expansion stroke. Here the pressure decreases and the volume increases, that you can correlate from the PV diagram. Then the exhaust. What is necessary? Now, the byproducts of the burning must be go out. So, for that what we require? We require the opening of exhaust valve. So, now the exhaust is open and inlet is closed. Okay. Piston moves from BDC to TDC. So, this is the fourth stroke. Again the 1 stroke length piston is covering. Crankshaft revolves half the rotation. Energy for this stroke is supplied through flywheel. Obviously, we are getting only out of 4 strokes, the 1 stroke we are getting power from the engine. Other 3 strokes are getting completed by the flywheel. So, the flywheel is performing that function. So, this is what the working of 4-stroke petrol engine. Okay. Burnt gases are expelled out. So, suction, compression, in between compression and expansion there is ignition of the burnt air fuel, then the power stroke, then the exhaust stroke. So, we can see the movement of piston from TDC to BDC, BDC to TDC, TDC to BDC, and again BDC to TDC. So, these are the 4 strokes, that is why it is named as 4-stroke. Spark ignition, SI engine, because the ignition of fuel takes place because of the ignition of spark. Constant volume heat addition, because the heat addition occurs at constant volume. So, this is the 4-stroke petrol engine working. So, here we can see all the 4 diagrams which I shown earlier in a single picture: compression, suction, compression, working or power stroke, or the exhaust stroke. Now, we can come to the another 4-stroke diesel engine. So, as petrol engine is known as Otto cycle, it is working on diesel cycle. So, Rudolf Diesel was the person, was the scientist who worked on this. So, that is why on his name it is known as diesel cycle. Compression ignition. In case of diesel engine, we do not have a spark plug. The ignition of fuel, ignition of diesel takes place only by the compression, self ignition. So, we are compressing the air up to the self ignition temperature of diesel. So, that is why it is named as compression ignition. Heat addition at constant pressure. Heat addition to the engine is at constant pressure. So, these are the common points which we can keep in mind. For differentiating between the petrol and diesel engine, we can also use these points. So, these are the points. Strokes are same because it is also the 4-stroke engine. So, the suction will be there, compression will be there, power stroke will be there, exhaust stroke will be there. If I have to observe the PV diagram here, so here is the clearance volume, this is the clearance volume. First the suction stroke, so the piston will move from TDC to BDC and the volume will increase. Okay. Then the compression, so then the compression, second stroke, this is the compression stroke, piston has covered the distance from BDC to TDC. Then heat addition at constant pressure because it is a diesel engine. Okay. So, it is a diesel engine. Here at the end of compression, the fuel is injected, here the fuel is injected. So, obviously the heat addition. Okay. Then because of the burning of diesel, the expansion will take place, this is the power stroke, and at the end the exhaust of air fuel mixture, byproducts of combustion. The main difference between the diesel and petrol cycle and diesel and petrol engine is, in petrol engine we are getting a gasoline mixture of air and petrol which is prepared in carburetor inside the cylinder. We are sucking In the suction stroke, we are getting the air and petrol mixture inside the cylinder, and compression of that air fuel mixture occurs. But in case of diesel engine, in the suction stroke, we are only inducing the air inside the cylinder. The compression of air takes place in compression stroke, and at the end of compression stroke, the diesel in atomized form is injected inside the cylinder with the help of fuel injector. So, the temperature inside is sufficient enough to ignite the diesel. That is why it is termed as compression ignition, okay, CI engine. So, this is the difference. All rest of the things are same. Okay. So, here we can see the suction stroke, the same point is there. Okay. Only the difference, the air is coming in. The air is coming in. Here we can see the air is coming in. Okay. Piston will perform all the functions same. Okay. All the points are same. I am not going to detail again. So, air enters the, here it is highlighted also, air enters the cylinder. Okay. Compression stroke, the inlet and exhaust are closed, piston moves from BDC to TDC, cranking required in first cycle. The compression ratio, now why the compression ratio is high? Because the compression is the only way through which the ignition is taking place. So, that is why it must be sufficient, the compression must be sufficient to get that sufficient temperature which is required for burning of diesel. So, here air will be compressed to a ratio of 1:20. Diesel oil is sprayed into the cylinder by injector and auto ignition takes place. Auto ignition means the ignition through compression takes place. Okay. So, all these points covered. Then the power stroke, piston moves from TDC to BDC after the burning. Okay. Inlet and exhaust valves will remain closed in both the strokes, compression and power stroke. Burnt gases generate energy and force the piston to move. Okay. Then the exhaust stroke, exhaust valve will open, inlet will be closed, piston moves from BDC to TDC, crankshaft rotates by half of the rotation, energy for this stroke will be supplied through flywheel. So, this is burnt gases will be expelled out. Okay. Here we can see the complete diagram in which the working of 4-stroke diesel engine is shown. Okay. So, the suction stroke, compression stroke, working stroke, or the power stroke, or the exhaust stroke. So, again I am emphasizing on 2 points. The 2 points are, first, 4-stroke engine. So, 4-stroke suction stroke, piston will move from TDC to BDC. Compression stroke, piston will move from BDC to TDC. Then burning of fuel will occur. Because of the burning, large amount of energy will be released. It will push the piston. So, piston will move from TDC to BDC. Then exhaust of byproducts, expelling out of the byproducts from the engine, from the cylinder. So, piston will move from BDC to TDC. So, these are the 4 strokes. So, these are the 4 strokes here. Now, I am coming to the petrol and diesel. Petrol engine, SI engine. The combustion of fuel occurs because of the ignition of a spark. So, a spark plug is there. Okay. In petrol engine, in the suction stroke, the mixture of air and fuel comes in and the heat addition occurs at constant volume. But in diesel engine, in the suction stroke, only air gets in and the compression of air takes place. The compression ratio is quite high as compared to the petrol engine, because the compression is the only mean through which the ignition will take place. So, that is why the compression ratio is quite high. At the end of compression stroke, the diesel in atomized form is injected inside the cylinder, then the burning takes place. So, these are the main points which we must keep in mind. I hope by watching this video you will be able to understand the working of 4-stroke petrol as well as the 4-stroke diesel engine. Thank you for watching the video. Thank you very much.